Okay. So good afternoon, everyone. Okay, so we are going to continue, okay, on this electrode potential. So under electrochemistry. So if you look at our previous lecture, okay, these are the videos, okay, that can serve as an extension to our lecture 9. Okay, so once you have, if you have these notes, okay, so you can go through all these three videos, okay. This will serve, okay, as a substitute uh, to the part, the calculation part, and so on, the investigation part that I didn't cover in the previous lesson. Yeah. So please go through these videos. Okay. But now for today, okay, we will enter this part, which is going to be known as electrode potential. Yeah. So when you have electrolysis, okay, when this we need to know that electrolysis is going to be a redox reaction where there is going to be reduction going to happen, oxidation is going to happen as well. And it is important also to know what is oxidation and reduction. So therefore, I think one of the easiest way to remember this is oil rig. Okay, oxidation is loss of electron. Okay, reduction is gain of electron. Yeah. So when this reaction, let's say for example electrolysis, okay, once the rate of electron gain is equal to the rate of electron loss, okay, we say that the cell has already reached redox equilibrium. So when we write equation, okay, you can see that most of the equation that we write, okay, is going to be in a reversible, will have this reversible symbol over there. Okay, that is important. Okay, and another thing is, okay, we know last time, okay, you would have learned that, okay, this metal, okay, can be reactive, this particular metal can be unreactive. Okay, so you remember the table and so on. Okay, now for our syllabus, okay, for A levels, okay, you do not need to memorize already, okay, because now everything can be found from your data booklet. Okay, but the important part is to know about how you can use them. Yeah. So here, okay, I'm just going to show you, okay, based on these two equations. Okay, this one is called half equation. Okay, please remember when we write the half equation, okay, always remember in this particular chapter, we are going to write the half equation in form of reduction. Okay, what is the meaning of in form of reduction? Okay, reduction is gain of electron. You see the gain of electron. Okay, electron is being gained. Okay, or in simple term, okay, always keep the electron on the left. Okay, when we write the equation. Okay, so please remember this first thing. Okay, the first rule. Okay, always, okay, always when we refer to the data booklet, okay, when we do our question and so on, okay, always remember the electron must be on the left. Yeah, must be on the left. It means it must be written in a reduction form. Yeah, so you can see this equation number 1, equation number 2 is written in reduction form. Now we know, okay, copper and vanadium are metals. Okay, and we know metals, okay, they have tendency to lose electron. Okay, that makes metal, right? Metal have tendency to lose electron. So if I say copper is being unreactive, it means that copper is not losing electron. Okay, they are not losing electron so much. Okay, so if I look at the position of the equilibrium, rather than losing copper, losing the electron, okay, they are going to have tendency not to lose electron. It means that the position of the equilibrium, if I look into this equation, the position of the equilibrium is more towards to the right. Okay, it's more towards to the right. And if you look at this reactive metal like vanadium, okay, vanadium is going to be reactive. It means they have a tendency to lose electron. So of course, vanadium will lose electron. It means vanadium will form the 2 electron and V2 plus. The position of the equilibrium is more towards to the left. Now, this one is important once you actually find out this. Now, what this will tell us, okay, this is going to tell us that, okay, I can come into a certain conclusion about copper 2 plus, okay, copper ion. Okay, copper ion, in this case, okay, you can see the position is going to be shifted to the right. It means that they have a good tendency, a very good tendency to accept electron or to gain electron to give you copper. Okay, it means that, okay, gain electron means reduction. So you see, copper 2 plus is relatively easier to reduce. Okay, and if you look at this second equation, okay, because, okay, I want to talk about V2 plus. Okay, because I know that the metal will give you the V2 plus, okay, the tendency for the V2 plus to form vanadium, which is to receive the electron, is going to be not so great. Okay, not so great. Okay, not so great. So because of that, okay, we can say that vanadium 2 plus, the ion, okay, is going to be difficult to accept electron or gain electron. You see, reduction is gain of electron. So it means that this V2 plus is relatively difficult to reduce. Okay, these are some of the things that you can come up with all these equations. Yeah. Now, if I move on further, okay, so when you look at different combination of metals, okay, in their solutions, okay, when you put inside their cell and so on, okay, what happens is the position of the equilibrium is going to be differ according to different combination of metal. So you see, in this case, vanadium position of the equilibrium is on the left. Copper, the position of the equilibrium is to the right. Okay, so they are going to be different. And we cannot measure directly, okay, the electric potential or the voltage of the metal and metal ions in the solution. We cannot measure directly, okay, but we can do something, okay. We can measure the potential difference, okay, with another system. Okay, if I say myself, okay, let's say, for example, I want to compare with one of you, okay, I am fat, for example. I want to say fat. I must actually refer to someone, okay, maybe a particular student who is very thin, okay, maybe Po Yiwen. Okay, if I say Po Yiwen, yeah, Po Yiwen is very thin. So I am fat compared to Po Yiwen. So Po Yiwen is my reference, okay? He is my reference. So the reference in this case, if I want to compare, okay, we use the reference as the standard hydrogen electrode. And do remember, standard hydrogen electrode, okay, the potential difference is going to be, we are going to use the E value is going to be 0.00, okay, because that is going to be your reference, okay, it's going to be reference. And what is actually standard hydrogen electrode? You can look at the diagram on the right over here. Okay, this one you need to memorize. Okay, you need to actually know how to draw. Okay, because, okay, they will ask you to draw. Okay, so you need to know. Okay, we are going to have the platinum wire over here. Okay, and you are going to have a glass tube. Okay, where it's going to be a supply of the hydrogen gas will come over here. Okay. And then there will be a platinum over here. Okay, they call it black platinum. Okay, this platinum, okay, you can see that they are coming into contact with the hydrogen gas. Okay, and half of it is coming into contact with the ion, which is going to be the H plus. This H plus ion can come from, okay, acid. Okay, maybe hydrochloric acid. Okay, sulfuric acid. Okay, up to you. But do remember, we mentioned about it must be under standard condition. Okay, so we call it E standard, right? So standard condition, okay, they must follow 1 atmospheric pressure. Okay, and then the concentration that you use, okay, it must be 1 mole per dm cube. And of course, okay, we do it at 298 Kelvin, which is going to be 25 degrees Celsius. So this one is important. And do remember, okay, if I write this cell, remember I told you it must be written in form of reduction. So how do I write? Okay, H plus, okay, and then I have electron to give me H2. Okay, this is the equation. Okay, and you need to balance it by just putting 2 over there. Okay, this is the equation, and the E value is going to be 0. Okay, it's going to be 0. And this is going to tell us, okay, this is going to be half of it only. And it is also telling that hydrogen can come out, yeah? So if a hydrogen can come out, okay, you can see a small hole over here, okay, where the hydrogen can come out, okay, in form of bubbles over here. Hydrogen can go out. Don't go and put the hole over here, okay? If you put the hole over there, okay, the hydrogen all come and will go out over here without reacting, okay? So please take note of that. Okay, so here, okay, if I move on, okay, you see here, this is what I've discussed earlier. Standard electrode potential, okay, must be, okay, whatever solution that you use, concentration must be 1 mole per dm cube, okay, temperature, and then 1 atmosphere, okay, and we call it the E standard, okay, that is going to be E standard. Okay, so this is very, very important. Later we will go through that again. Yeah. So here, okay, what E standard or electrode potential tells us actually. Okay, this is going to tell us how it is, how easy it is to reduce a substance. Again, if you are confused, reduce. What is reduce? Reduce oil rig. Reduce is gain of electron. It means it's going to tell us how easy something, okay, can gain electron. Okay, and this one I'll teach you a trick, a very important trick. Okay, what is the trick? If you look at something that is positive, you see, yeah, the first thing, okay, the equation must be, okay, we need to make sure the equation must be in reduction form. You see, both of these reaction 1 and 2, they are in reduction form. Okay, they are in the reduction form. And the trick is, okay, when you have the voltage, let's say, for example, the E value is more positive, for example, more positive, okay? Positive, you think it will go to the right, okay? Positive, it will go to the right. You think like that. Positive, it will go to the right. If it is negative, okay, later I'll teach you more detail, yeah? So now I just want you to remember, if it is negative, think it's going to go behind, okay, reverse. Okay, now this one, okay, will help us to answer a lot of questions. Yeah, so you see, this is the voltage given. This is the voltage given. So what does it mean? Okay, the meaning is, okay, you see the metal on the right. What is the metal on the right? Okay, silver. Okay, this silver, you see that, okay, this ion react. It means will join with the electron to form silver. Therefore, silver do not have tendency to form the ion and the electron. And you know, reactivity of metal. Metal tends to lose electron to become, to say that this is reactive. In this case, this silver is not reactive because they are not going to form a lot of electron. Okay, because the position of the equilibrium is going to be to the right. And what is this? Poor reducing agent. Now, this one also remember, what is the meaning of reducing agent? Reducing agent is something that will reduce others, but itself will undergo oxidation. So what is oxidation? Oil. Oxidation is loss of electron. Now, silver, can it lose electron easily? The answer is no. So that's why they are poor reducing agent. You can come up with the conclusion over here. If you use the same situation over here for the second equation, you see the metal on the right, you see zinc. If I compare with silver, I can say that zinc metal is more reactive. Why? Because zinc can form electron. They can give out electron easily because the position of the equilibrium is towards to the left. Okay, so it means I can say relatively reactive. Okay. And it's a good reducing agent. What is reducing agent? Reducing agent is something that will reduce others, okay, but itself will undergo oxidation. What is oxidation? Oxidation is loss of electron. Can zinc lose electron easily? The answer is yes. So they're good. Simple as that. Okay. So if you look at that, I have already explained this. Okay, but yeah, of course, we will refer this again and again, and therefore, okay, we will do some checkpoints over here. Okay. Now I am going to give you these two equations, and do take note. Both of them, okay, they are in form of reduction. You see the way they are written in this way, and you can see here, okay, positive, negative. Equation number 1, equation number 2, and according to what I said, yeah, if you want to compare, if you have something that is more positive, okay, equation number 1, positive, go to the right. You put, okay, you put. This is negative. You go and put this arrow over there. That is the first thing that you put. Now, if you want to answer the question over here, which one is a best reducing agent? You're comparing between these two. Now, best reducing agent. What is reducing agent? Something that will reduce others, okay? But at the same time, they will get oxidized. What is oxidation then? Oxidation is loss of electron. So I need to find out, because I need best. So it means I need to find out which one can lose electron easily. You see, between this and this, which one can lose electron easily? Automatically, if you look over here, this one add electron to give you this. Cobalt, okay, is the one that will lose electron, okay, easily. So the answer is going to be cobalt. Which metal ion in the list is most difficult to reduce? Cannot understand what is this. What is reduce? Gain of electron. Okay, so I need to find out which of these cation, okay, can gain electron, cannot, difficult to gain electron. Okay, which one difficult to gain electron? Because it's going to the right, this one can gain electron easily. This one, because it's going this side on the left, cannot gain electron because it's not going there. Okay, so the answer is going to be CO2 plus. And which metal in this list is the most reactive? Metal is what? Metal is something that will lose electron. So you see, this is the cobalt, okay, compared to silver. Cobalt is the one that will lose electron easily. So most reactive is cobalt. Which metal ion in this list is easier to reduce? Quite easy. What is reduce? Reduce is gain. Okay, so which one can gain easily? This one, okay, Ag plus. So it's all starts from the arrow. Mr. Gopi, very, very fast. I don't understand a single thing. It's okay. We go checkpoint 2. Similar way, yeah. Similar questions also, yeah. So you see here, okay, the voltage is going to be negative 0.28. Positive 0.34. What you do first? The first thing, more positive. This is going to go to the right. Okay, so this one will go to the left. This is the first thing you do. Which metal in this list is the best reducing agent? I don't know. What is this? Reducing agent, something, okay, that will reduce others, but they themselves will get oxidized. What is oxidized? Oxidized is loss of electron. Which metal will lose electron easily? This one. Okay, you can see the arrow. And which metal ion in this list is most difficult to reduce? Reduce is what? Gain of electron. Which one difficult to gain electron? This one easier. Okay, this is going to be difficult to gain electron to go there. So this is going. Okay, sorry, I got disconnected for the list. Which one is more difficult to reduce? You can see is CO2 plus. Okay, difficult, cannot go there. Yeah, so still, okay, I still don't understand. So, okay, let's try another one. Okay, checkpoint 3. Okay, you see here. Okay, same method. More positive, negative. More positive, you bring over here. This one, go here. Okay. Which metal in this list is the most reactive? Metal means must lose electron. Which one can lose electron easily? You can see this one. Okay, so it means Pb. Which metal ion in the list easiest to reduce? Okay, what is reduce? Reduce is gain of electron. So which one can gain electron easily? So this one. Still confused? Okay, we go another one. Okay, so here, okay, you have a different situation. Oh, Mr. Gopi, you said must be positive. Now nothing positive. Then in this case, okay, you need to select the one that is going to be most likely or closer to positive. It means closer to 0. Yeah. So if you put in number form, okay, so if this is 0, okay, negative 0.13 is here, and then negative 0.76 is here. So this is going to be more positive, closer to 0. Yeah. So we select the one that is going to be more positive to go to the right. Okay. So here, automatically this one will go to the right, this one will go to the left. Okay, now you can tell, yeah, about this. Okay, if I say which metal is more reactive, what is reactive? Metal means they lose electron, so the metal that can lose electron more reactive is zinc. Okay, more reactive. Okay, most reactive. And then if I say which one can easily become, let's say I change a bit, which one is good, a very good oxidizing agent? Okay, which one is a very good oxidizing agent? So what is oxidizing agent? Okay, oxidizing agent is something that will oxidize others, okay, but they themselves will get reduced. Okay, so what is reduced? Reduced is gain of electron. One is going to be gaining electron easily. You see this Pb2 plus. So Pb2 plus is best oxidizing agent over here. Come up with all these conclusions based on this simple strategy. Okay, what is important? The simple strategy is positive. Okay, the most positive, then they go to the right. Okay, then less positive. Okay, or negative, go to the left. This happens when you are comparing. Okay, when you're comparing. Okay, now if you look at this electrochemical cell, okay, so do remember just now in the beginning we started with electrolysis. Now, what is the difference between electrolysis and electrochemical cell? Simple, only one difference. Okay, electrolysis, okay, they need to use battery. They need to use electric current, power supply. Okay, to move the ions, okay, to move the electrons, okay. But electrochemical cell, you do not need to do that because, okay, this electrochemical cell, they are going to have two different metal, okay. Two different metal, okay, they will have potential difference, okay. And this potential difference itself is good enough, okay, to make the electron to move and make the ion to move. Yeah, so you do not need to supply the power supply for it to move. Yeah, so you can see here, okay, the setup of electrochemical cell. Okay, one thing that you will notice is why there is two beakers then. So do remember we are using two different metals. Okay, so they must have their own ions. Okay, zinc ion, zinc rod, then zinc ion, copper rod, copper ion. Okay, you cannot mix them together. Okay, but I need to put salt bridge. Okay, what is salt bridge? Salt bridge is going to connect the circuit. Okay, how? Okay, do remember. Okay, some students they think, okay, salt bridge is there. Okay, electron. Do remember, electron can only move, okay, in the external circuit. What is external circuit? The wire. Okay, electron can move over here. Okay, this is negative terminal, so electron move over here, go there. Okay, this is the way how electron moves. Okay, don't go and tell electron suddenly they swim over here, they jump, and then they climb over here, they jump over here, jump over here, jump over here, they come over here. No. Okay, that is not going to happen. The one that is going to be moving around the salt bridge is going to be the ion. Okay, that is very, very important. So salt bridge, okay, is going to make the circuit to be complete. Okay, and at the same time, it is going to separate. Okay, we want the solution, the electrolyte, to be separated. So it serves two functions over there. So salt bridge is going to be there, okay, and normally we use, okay, potassium nitrate, or we can use sodium nitrate. Okay, we debate later. The next slide, I will talk more about salt bridge. But if you look over here, okay, this is going to be copper cell, and then you have zinc over there, copper and zinc. If you look at the voltage, okay, now let's apply what we have learned. Okay, now if I look at this voltage, this is going to be positive, this is negative, this is going to go to the right, and this is going to go to the left. Okay, do remember this. When it is going to the right, okay, you can see that copper ion gaining electron. Okay, copper ion tends to gain electron. So when I write the equation, okay, if let's say I want to write the half equation of this, okay, the half equations, okay, what is going to be the half equation? I write copper 2 plus 2 electron, nothing changed over here. So I just simply write, and then I put plus 0.34, nothing changed. But when I write the half equation for this particular cell over here, because it's going to the left, do remember, electrolysis and all these things are going to be redox reaction. There will be one oxidation, another one is reduction. So this one, it will follow zinc, is going to give you zinc 2 plus 2 electron. Now, do I put negative 0.76 over there? The answer is no. The moment you flip the equation, okay, the moment you reverse the equation, automatically the sign will change, plus 0.76, okay, automatically. And, okay, another thing is, when I write the final equation, okay, what I will get, normally we want to achieve, okay, we want to get rid of the electron, okay, we add, right? So I will get Cu2 plus zinc, okay, copper, okay, plus zinc 2 plus, okay. So what is going to be my total E value over here? You just add, okay, 0.34, okay, 0.34, you add with 0.76, okay, it's going to be 1.1. Okay, that is going to be the voltage that is going to be generated, which you can calculate. Okay, this one, okay, I'm just teaching you only one way. Okay, what is one way? Okay, the first thing is going to be when you write the half equation, you adjust the equation accordingly, and what happens to the sign? The sign changes. Okay, this is only one. Later, I will teach you another requirement. Okay, there is another requirement. I will come back to this again. Yeah. So now I will just move forward. Okay, you see salt bridge. Okay, what is a salt bridge? Just now I already mentioned to you. Salt bridge. Okay, you take a strip of filter paper, you soak in saturated solution of potassium nitrate, or you can use sodium nitrate. No problem. Okay, but okay, if there is going to be question like this, you see, suggest why silver nitrate. Okay, it's not used in a salt bridge. Okay, when you are connecting with zinc and zinc chloride. So what will happen? Okay, if you do that, okay, you see here, if I put, okay, silver nitrate, okay, inside my salt bridge, it means that there is going to be silver ion, there is going to be nitrate ion. And, okay, here, okay, let's say in this example, there's going to be Cl minus ion and zinc ion. Okay, what happens, okay, when they come into contact, okay, because I want the ions to move, right? So what happens is silver ion, when they react, they will form silver chloride. And this one, as chemistry student, you should know, yeah, silver chloride is going to be precipitate. You know in detail also what kind of precipitate, what color, yeah, chloride. Okay, chloride is going to be a white precipitate will be formed. So what happens over here, because I want the ions to kind of jump and move and swim over here, I don't know, but suddenly when you have the precipitate, it's like a big stone, okay, will actually appear, okay, and then will block the movement, so which I don't want. Okay, which I don't want. So this one, okay, we will suggest, okay, don't use silver nitrate. Okay, you don't dip into silver nitrate. The best is to dip in potassium nitrate. Why? All potassium, group 1 potassium and sodium salts, okay, they are soluble. Okay, so you won't have that problem. Okay, potassium nitrate, okay, and then sodium nitrate, you can use them. All nitrate salts also are soluble. Okay, so you won't have you no need to think, oh, can I use this? Can I use this? Can I use silver nitrate for this, but not this? No need to think. You use these two, okay, you no need to worry about, okay, this salt bridge is not going to work. Yeah, you no need to worry about that. Yeah. Now, next, when you measure standard electrode potential. Now, just now, remember I told you, okay, if I say Mr. Gopi is fat, okay, I told that I need to compare with the student just now, even. Okay, so it means when I'm comparing the reference is the hydrogen cell, right? Now, when you do that, okay, there will be a lot of different type of people that we are going to compare. Maybe Mr. Gopi. Okay, maybe we are comparing with Ryan, maybe we are going to compare with Harry, maybe we are going to compare with Wilson. Yeah, we don't know. Different people, okay, will have different requirement, yeah, maybe they are different. Yeah, they are different. So you see, okay, we have three different types, okay, of half cell, okay, that we can compare. Okay, one is going to be metal and metal ion. Okay, this is, I think, very common, metal and metal ion. For example, if I have zinc, zinc is metal, okay, metal ion, so zinc 2 plus. Okay, this is very common. We can also have situation where, okay, non-metal, for example, Cl2. Cl2 is non-metal. So if I want to compare, so Cl2, maybe I need the Cl minus, okay, Cl minus. So you see, it's going to be a non-metal ion, Cl minus. And then ion and ion, okay, we do have the situation where we have Fe3 plus and then Fe2 plus. Both of them are ion, okay? And we are going to compare, okay? We are going to find the E cell, okay? So I will go through one by one, okay? You see here, okay, if I have this, for example, metal and metal ion half cell, okay, what I need to do, you see, the first half over here, we already learned, okay? This one is going to be always hydrogen, yeah? When you need to know how to measure, yeah? How to draw, yeah? And then the remaining half is going to be, because it's going to be copper and copper ions, right? You see, copper ions and copper. So the copper, okay, the metal, okay, will become the electrode, okay? And then the copper ion, you put it over here, quite simple, okay? But you need to make sure that they are in 1 mole per dm cube, 298 Kelvin, okay? And then you put the salt bridge. It's okay. Okay, this one you no need to worry. Okay, this one you can easily get it from the data booklet. Okay, so how to use and so on. Okay, I already explained to you earlier. Yeah, I already explained to you earlier. But okay, maybe I'll teach you something over here. Okay, what I can teach you over here is, maybe let's actually find out which one is positive terminal, which one is negative terminal. Okay, now if you look at this value, do remember, okay, when I taught you, this is going to be always 0, yeah? So you see here, this is positive. This is 0.34 is more positive than 0, okay? So it means that the position of the equilibrium is going to be to the right. This one is going to be to the left, okay? When I write the equation, the half equation, okay, it will be Cu2 plus, okay, plus 2 electron to give you Cu, yeah? And then there will be another one, which is half H2. It's going to give me H plus and then electron, which is going to be 0.00, because negative, no need to change. Yeah. So it's already 0. Yeah. So this one is going to be 0.34. If I want to find out, yeah, I just add, okay, you get 0.34. No need to worry. Okay, when I times by 2, do remember, okay, if I want to cancel the electron, okay, I need to times by 2, yes. Okay, but this value, okay, we are not going to times by 2. Okay, later I'll give you some other example. But what I want you guys to see over here is, based on this equation, okay, let's see which one will lose electron. You see, hydrogen is the one that will lose electron. Okay, anything that loses electron, okay, if you studied physics before, okay, that is going to be your negative terminal. Anything that will gain electron, okay, that is going to be, the electron is kind of jumping over here, jump over here. That is actually movement of the electron from the hydrogen. Okay, then they will come over here. This is accepting the electron. Therefore, this is going to be a positive terminal. Okay, you need to know this. Okay, so this is extra thing that I teach you. Okay, but now let's look at the checkpoint. Okay, so here, okay, you see, draw a diagram to show how you would measure the standard electrode potential for the following half cell. Okay, so how do you analyze over here? So the first thing is, oh, this is zinc, this is metal, okay, and this is zinc 2 plus. This is going to be metal ion. So this is going to be a metal ion setup. So you just need to put zinc as the electrode and then zinc ions. Okay, over there. So you will see that you will end up having this kind of setup. Okay, you see zinc ion, and you should be able to draw. And then the same thing I told you, you can identify which one is positive terminal and negative terminal. I'll make it very fast. You see, this is positive, this is negative. Okay, more positive will go here. Okay, it means that H plus, okay, add electron. Okay, so this one will go here. Zinc is the one that will lose the electron. Okay, so if zinc is losing electron, electron is moving from here to here. Okay, so this is negative terminal, this is positive terminal. Very easy. Yeah. Okay, but I will move on. Okay, that is going to be the first situation. Okay, so metal and metal cation. Now, okay, we will look into second situation, which is going to be non-metals and non-metal ion. Okay, so you can see similar. Okay, we are going to compare with the hydrogen. So this one we have already learned. Okay, the setup is all the same, but in this case I'm using chlorine gas, okay, which is going to be a gas. So if it is gas, gas is non-metal. Okay, if it is gas, then you need to do something similar to hydrogen. You put them in the tube, okay, and then you put the platinum wire, you put the platinum over there, okay, and then you make sure the platinum is coming into contact with the Cl2, okay, and make sure the platinum is in contact with Cl minus as well, the solution, yeah, and then put a hole over here below, okay, and then so that the Cl2 can go up, yeah, something like that, okay. So this is going to be the setup. Okay, but again, okay, if you want to find out which one is going to be positive terminal, negative terminal, you can use what I taught you. Yeah, positive, less positive. This will go here. This one will go here. Hydrogen gas is the one that will lose electron. So hydrogen gas will lose electron. Electron will move from here to here. Okay, so electron going out, so this is going to be negative terminal, this is going to be positive terminal. Yeah, so quite easy. Yeah, but okay, let's actually go for another one, another checkpoint. Now, just now we did for chlorine and then chloride ion. Okay, but here you see this is very special. Iodine, okay, at room temperature is solid, and then iodide is going to be aqueous. Now here, this is going to be non-metal, but in solid form. And then you have metal ion. So you don't go and put, okay, a glass tube like just now for the gas. Okay, you do not need to do that. Okay, but make sure, okay, whatever, when you put the platinum wire, okay, and the platinum, make sure that the platinum comes into contact. You see, this is iodine solid. Half of it is coming into contact with the solid. Another half is going to be coming into contact with the I minus. Okay, so you put, okay, so it means the solid is going to be at the bottom, and then aqueous will be at the top, and then as usual, okay, the salt bridge is going to combine, and then it's going to make the reaction to happen. Yeah, it's going to complete the circuit. So this is how you draw. Yeah, so if you recall back again, okay, for non-metal and non-metal ion, there are two types. Okay, one is related to something that has gas, okay, which is the Cl2, or it can be something that is going to be like solid, yeah, something like this kind of setup. So you need to decide, okay, which one you are going to use. Okay, so that is going to be very, very important. Okay, so anyway, okay, now we go for the third setup. Okay, the third setup is going to be very, very simple. Okay, compared to the others. Okay, like for example, if I have this kind of situation, okay, I want to find the E value of this, but you see, this is also ion, this is also ion. So, okay, what we need to do, we just need to put both of those ions together. That's it. Okay, so half of it is going to be the same, okay, like what we have learned. And then this one, just put platinum wire, okay, and then you just need to make sure that they are in 1 mole per dm cube, okay, under standard condition. You put all of them together, mix, okay, Fe3 plus and Fe2 plus, mix. But you need to be very, very careful when it comes to ion cell, half cell, yeah. Why? Okay, this is very common mistake, okay, when it comes to students. When they say, draw a diagram to show how to measure the standard electrode potential of this particular cell, or students will say, oh, this is aqueous, mix them together. Okay, everything finished. But what you students forget, Okay, when you write the half equation for this, I think last time when you learned about redox reaction, you should know when you balance the equation, there is going to be hydrogen ions will be there. It means that's why most of the time, okay, when you use potassium manganate, it must be acidified. And let's say, Mr. Gopi, I don't know where this equation comes from. If now you're not sure, it's okay. This equation can be found from the data booklet, okay? But make sure, okay, when you write, you want to draw for the half cell, check, okay, whether there are going to be different aqueous ion that will be involved in the equation, okay, which is going to be the H plus. So what you need to do, you see, students will just give this and this. If you miss out this, you will lose mark. It means you need to also give this. You mix 3 of them, okay, you mix 3 of them. And that is going to be what you need to take note. Yeah, very, very important. And again, okay, how to identify which one positive and negative. Yeah, that one I already told you, and I already teach you how to do. Okay, so therefore, okay, you see, we'll just go for another checkpoint. Yeah. So you see this particular checkpoint, okay, with the aid of the diagram, how would you measure this, for example? Okay, and you see this is going to be aqueous ion, this is going to be aqueous, okay, so this is going to be ion, and then there is going to be H plus. So now we know there will be 3 ions there. So I need to draw and I mix all 3 in 1 mole per dm cube. Okay, this is what I need to do. Yeah, this is how to draw. Okay, now this one, no need to be surprised. This is something new. No, this is not new. Okay, from just now, okay, that I was teaching you, I have actually taught you all this, okay, which is now it is going to be, you should be able to do this very easily. You see, yeah, when I want to find the E value, yeah, if you have 2 cells and then I want to calculate the voltage, quite simple. Okay, you see, more positive, go this side. Okay. So when I write the equation, it's Ag plus electron to give me Ag. So it's going to be 0.80, no change. So this one is more negative, so it's going to go this side. So when I write, it's zinc, is going to change into zinc 2 plus 2 electron. So when I rewrite the equation, it's going to be the other way around. So plus 0.76. Okay. Now, when I combine this equation, okay, do I need, because now I need to actually cancel the electron, right? So I normally, last time we learned, okay, this one, everything times 2, okay, then only the 2 electron and 2 electron will cancel. Do I need to times by 2? The answer is no, never do that, okay? Don't do that, okay? This is not the same, okay, as your enthalpy, okay? The only thing that will change, okay, is going to be the sign. Okay, you do not need to times by 2, divide by 2, anything, just leave it. Okay, so here, okay, is going to be, when you want to write the equation, then it's going to be 2 Ag plus zinc, and it's going to give you 2 Ag plus zinc 2 plus. And then if I want to find the E value, just add these 2. Okay, so when you add these 2, you will get positive 1.56. Done. Okay. Don't actually think about minus, plus, all these kind of funny formulas. Yeah, so you change over here and then you add. Okay, you add. Okay, similar like what you add the equation, right? So you add. Okay, so the same thing, you see, I have already explained over here. Okay, but I will move over here. Okay, you can see if I want to calculate the voltage. Okay, same, positive. Okay, both of them positive. So this is more positive. This will go here. This will go here. Once you are already expert in it, okay, no need to rewrite 0.77. This one go here. So negative 0.34. You add this, okay? So it means it's minus. So it's going to be positive 0.43. Okay, once you're very good at it, okay, you will know this. Okay, now all these are the data, okay, that is given in your data booklet. Okay, and you can see, okay, there are many. Yeah, there are many. But it is important to select the correct one. Yeah, so be very careful. Okay, so you see here, I gave you all this taken from your data booklet. Do not use the value in the textbook, okay, because every time when you calculate, let's get familiarized with the data booklet. Yeah, so let's actually use that. Okay, so here you see this example. Okay, when they say draw a diagram of electrochemical cell consisting this cell. Yeah, so now you see, now I'm not going to find the E value, yeah, the standard value. So now I'm just comparing 2 electrochemical cells. Okay, so when I draw, okay, use whatever three things that I call you, which is the metal and metal cation, non-metal and non-metal ion, and then ion and ion. You apply, okay, you apply. So here you see, this is going to be ion, and this is going to be metal. Okay, so make sure, okay, there is going to be electrode of chromium, okay, and then solution of Cr3 plus. Here you see this is gas, non-metal, okay, then there is a solution. So what you do, make sure there is a gas tube, okay, give the Cl2, and then there is a platinum wire, okay, and then the platinum, okay, and then it comes into contact with Cl2 and then the Cl minus. So you should be able, okay, to draw like this, okay, like what I mentioned to you just now. Okay, this one you should be able to draw by now, yeah, and you can see what are the information that you need to give. Okay, all these information are quite crucial, yeah, you must write it down properly. Now if I want to calculate, okay, you see here, when they say Cr3 plus to become Cr, it means it's going to be plus 3 electron. We are looking into this equation. And then Cl2 to become Cl minus, okay, so they are looking into this equation. So what you need to do, you have to refer, okay, to your data booklet. And I took the value over here. You see Cr3 plus, you see Cr3 plus, there's many, okay, but I need to go to Cr, okay, Cr3 plus and Cr. So make sure you select the correct one, okay, negative 0.74. Negative 0.74. This one, okay, for Cl2 plus 2 electron, 2 Cl minus, then it's going to be 1.36. Now I'm going to compare, okay, between these two. Which one is more positive? You see, this one is more positive compared to this. This one will go here. This one will go here. Okay, so when it goes there, okay, when I write down, I will write down, okay, as it is, Cl2 plus 2 electron to give me 2 Cl minus 1.36. This one I write Cr, okay, is going to give me Cr3 plus 3 electron. Now I change the position, right? So it's going to be positive 0.74, okay. Now this one I just simply add, okay. When I simply add, I will get 2.1 positive, okay. And for this one, okay, do I need to times, sir, this one times by 3, right? Times by 3, okay, times by 3, times by 3, times by 2, times by 2, times by 2. Do I need to times by 3, times by 2? The answer is no, no need. Don't do that. Okay, you don't do that. Okay, what you need to do is when you write the full equation, then you write 3Cl2. Okay, the electron, the 6 electron is already gone. Okay, and then plus 2 Cr, okay, to give you 6 Cl minus, okay, plus 2 Cr3 plus. Okay, this is the full equation. Okay, but this is going to be the E value. Okay, and you can identify also which one is going to be okay, sorry. Okay, I will continue again. How do you identify the positive terminal? Okay, quite simple. Okay, you see here, okay, Cr is the one that will lose electron, will give out the electron. Okay, so it means Cr is the one that will give out the electron. Electron will move from here to here. Okay, electron move over there. This is negative terminal. This is the positive terminal. So if you want to identify which one is the positive pole, okay, this one, this entire cell is going to be positive. Quite simple, yeah. So the same thing, okay, you can apply, okay, this one we can go very fast, okay, you see Mn2 plus and Mn, okay, Mn2 plus, okay, and then plus 2 electron to give you Mn. And then Pb2 plus, okay, plus 2 electron to give me Pb. Okay, so you see this is metal, metal ion, metal, metal ion. So the way you draw, okay, so it's going to be electrode and the ion. Okay, once I do that, I just need to calculate. So you look at the data booklet, okay, Mn2 plus 2 electron to give you Mn. So this is going to be negative 1.18. Okay, so for Pb2 plus to give you Pb, so negative 0.13. So you need to find out which one is more positive. So more positive is this one, closer to 0. Okay, and this one will go here. So if I want to write down, okay, or when I want to identify, okay, if I want to calculate only, okay, let's say I want to calculate only, this is going to stay negative 0.13. This one is going behind, reverse. So it's going to be changed, plus 1.18. Okay, when I join these two together, okay, what I will get? I will get positive 1.05. I can calculate. Okay, I can calculate. And I can also write the full equation. And then if I want to find what is the positive pole, very simple. Just now, you see, this is going to go here. Mn is the one that will lose electron. So if Mn is the one that will lose electron, electron will move from here to here. So this is negative, this is positive. Okay, so they want this. So this is going to be the answer. Let n Pb and Pb2 plus and Pb. Okay, the same thing. Okay, the same thing. Okay, anyway, okay, this one, okay, we have finished. Okay, so if you have any questions, okay, you can ask me now. Okay, there is no quizzes. Okay.